Alright, time for another DraftPhysics.com, debatephysics.com also, but no reasonable argument, counter-argument, no discussion, no anything, just insults and shit talk. So, I'm going to play an Al-Kahari video titled What Matter Makes Up Our Known Universe. What matter makes up our known universe? I don't know what the original title was, but this is a terrible title. This is some kind of spark that puts up his videos. But anyway, thermodynamics, and it's all so wrong. It starts with Leibniz, so that's where I want. That's why I like it. It can make my argument just how they can't they just can't tell the truth about anything. It's just all such nonsense. So I wanted to talk about thermodynamics and the big lie that this, the video ends with this conclusion that somehow all energy disperses. And the true fact is that's not what's happening in our universe. And if they had matter right, they'd figure that out. Now, there's key places in this video. I don't know if we're going to get to those key places because it takes forever to play through all the bullshit. But where they talk about how heat goes from hot things to cold things. Well, you could argue so does pressure. It doesn't have a choice. So that's not a news flash. That somehow they think that dispersion, is forever. And the fact is that heat also creates radiation, infrared radiation. And that radiation goes back into the universe, so to speak, as the pressure in the universe that ultimately, wait for it, causes gravity, right? And so gravity is the most anti-entropy mechanism. And because they call it bent space and they don't recognize it as part of momentum, they don't think something with momentum is causing the momentum. So the momentum you have falling in gravity, they don't think that's being caused by something that has momentum and it's giving you the momentum. And not to mention the fact that the kinetic energy theorem has nothing to do with the reality, It's momentum. All that's transferred in the universe is momentum, and it goes from little tiny things, the force bits, to matter bits, electrons and protons, and then they can be in big collections of atoms and blah, 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 big things. But it's just pushing electrons and protons. That's all the universe does. That's all that's in it. And so when the force is free, it's creating pressure. When it's not free, it's caught up making pressure. So it's not going the speed of light anyway, and it's pushing matter. So there's the thing that restructures the universe, that is, makes it seem to go from something more chaotic and disarrayed to something completely ordered, is gravity. Gravity is an order-making device. It's taking energy going in all directions and, in a sense, making it go in one direction. Merely by putting a piece of matter in the field, you convert a chaotic energy field into one that's producing momentum in one direction. And so the order is restored, in a sense. And certainly it's the foundation for the whole process, which is you create the pressure. The pressure is real energy. The pressure ends up igniting a sun, for example. It ends up producing a bunch of photons. The photons hit other surfaces and cause complexity. So there's a huge engine doing the exact opposite of falling apart. And so it's just, there's no truth to the assumption that energy flows one way and then dies. It doesn't die. It goes back and creates the very processes that created the complexity in the first place. So it doesn't end in disorder. There's no obligation for the universe to exhaust itself. Now, the only issue would be is the container for the universe. You could argue that it's going to lose energy because photons keep going through the empty space forever if they don't hit something. And so if there's nothing for a photon to hit, where does it go? Okay. So you certainly have to have a container for the universe of some kind that forces the energy back into the system, or you have to have an infinite universe. One or the other. But anyway, the recycling happens. There's no heat death. And it's mostly because they don't recognize gravity as heat being created by a force, being created by energy that came from somewhere. The little bits, okay, are expelled by things eventually. So if I put something hot in space, it doesn't vibrate atoms. It doesn't dissipate its heat by going to something colder. Okay, it dissipates its heat as little bits of radiation, photons. Fact. It doesn't say that fact in here. So they construct this whole argument. It really is just a religious narrative. The truth doesn't have much to do with the story, and it's just tailored to emphasize the points they want to make, and very important facts are left out. So we'll let him do his. This is the show. This is what people want from their scientist. Is this crap? This religitainment.
How did humans acquire the power to transform the planet like this?
So we know we got most of that power by tapping old dead fossilized reserves of solar energy. So the sun shined down on the earth for millions of years. A ton of the stored chemical energy was sunk into the ground, okay, the carbon sinking, and we figured out to tap it and liberate, take the energy back. So the more complex atoms have more energy in them, and so if you can grab these more complex atoms and break them down a little bit, you can steal some energy out of them, some originally solar energy.
Looking at the Earth at night reveals to us just how successful we've been in harnessing and manipulating energy, and how important it is to our existence.
Right, and the success is based on, right, all the wars, all the bullshit that's going on, and the fact that it's not a sustainable resource, and we're going to have, something like egg on the face because we're not going to be able to civilize the rest of the world because we're going to run out of energy. Or it's going to be too dirty. We'll keep going for the cheapest alternative, and there's a lot of coal to burn.
Energy is vital to us all. We use it to build the structures that...
So energy is just momentum. That's all it is. It's just something moving. So anything moving is energy. Big thing, elephant moving, bird moving, atom moving, electron moving, force moving. That's energy. Something moving. All right. So I'd argue that obviously the force that's in the universe, it is the only thing that has motion innately or elementally, and it just pushes things. So all the electrons and protons are just being pushed around in a field of force, and it's just about a balance in that field. Create an imbalance in the field, and it moves in the imbalance. There's no pulls. There's just pushes, and all you can do is reduce the amount of push on one side or increase the amount of push on one side to cause attraction and repulsion.
Surround and protect us. We use it to power our transport.
La 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 la. I mean, all this extra gibberish, right? This is show physics. This is what human beings are hungry for.
And light our homes. And even more crucially, energy is essential for life itself. Without the energy we get...
So it's just silly to say movement is essential to movement. You need movement to cause movement. There we go. I mean, done, right?
From the food we eat, we die.
So the movement inside of a cell is movement, you're inside of an atom is movement of the electrons and protons in the sense of the pressure between them. Again, the denser the atom, the more force it's carrying.
What exactly is energy, and what makes it so useful to us?
So again, energy is just movement, and you're just saying it goes, yes, there's every possibility that you can take coherent energy in one direction, and turn it into energy in all directions. It's really easy to diffract energy, scatter energy, just a fact. And it's harder to funnel energy. So if I was to use the example of heat, heat is this transfer inside of an object, by the atoms' contact with each other. So the atoms are in all directions, so the heat goes in all directions. But frankly, motion is just heat in one direction. It's the same exact mechanism. It's just saying instead of you jiggling, you're going in one direction.
In attempting to answer these questions, scientists would come up with a strange set of laws that would link together everything from engines to humans to stars.
And there's no link. The theory basically is saying something's true that isn't apparently true at all. I mean, there's no real evidence the universe is getting colder and colder and colder or any of that crap. So, wrong.
It turns out that energy, so crucial to our daily lives, also helps us make sense of the entire universe.
Right, so they don't make sense out of it. They have a bunch of woo in it, a bunch of entanglement and superpositions and 400 particles that don't have a place. You can't draw them where they are. Where do positrons live?
This film is the intriguing story of how we discovered the rules that drive the universe.
So it's really just the story of the little, the few people who got to influence more than they should have, that none of the physics was ever tested. They just adopted it. There was just stuff they decided to put in the book, and that became, their dogma.
Yes. It's the story of how we realized that all forms of energy are destined to degrade and fall apart.
So that argument is just wrong. It's a tendency, okay, again, disorder is easy, okay, scattering is easy, okay, collecting and funneling is more difficult. That's a fact, but it's happening right now. Right now there's gravity, and it's pulling matter into clumps, and those clumps have decidedly symmetrical stores of energy. It's being ordered right before your eyes. I mean, it's obviously being organized into suns, and the suns are now organizing the atoms into denser and denser material, taking hydrogen, turning into helium, blah, blah, blah.
To move from order to disorder.
So, right, so there's complete order in going from hydrogen to helium, and then helium to lithium, or whatever the next, and onward and upward. That's evidence of order. So we have a clear piece of evidence that they're not going to talk about. A clear piece of evidence that the universe right now is making ordered and more complicated compounds.
It's the story of how this amazing process has been harnessed by the universe to create.
So this is really silly talk, right? That the universe harnessed something, and the universe is. Just as your brain is you, okay? The universe just is. It doesn't do anything. It just happens.
It's everything that we see around us.
So all we're seeing around us is what the Descartesian notion that the energy is just, and it's also a Leibnizian notion, the energy is just moving through the system. It's just being converted from one form to another, and it just keeps on moving through the system. And yes, it can be converted into little stuff, and the little stuff will cause the small stuff to repressurize inside of suns. So you can dissipate the pressure, and then the suns rebuild the pressure. So that's probably what the title originally was, Order and Disorder. So, and it's just the same thing. It's just energy in small pieces, energy in big pieces, and you could argue the smallest piece is the force itself, the biggest piece is whatever, galaxy. So the story of energy really should be the story of momentum. It's just mass moving. That's all there is in the universe. Just a mass moving a velocity. And that has to be conserved. And there's no other players.
Over the course of human history, we've come up with all sorts of different ways of extracting energy from our environment. Everything from picking fruit, to burning wood, to sailing boats, to water wheels. But around 300 years ago...
Yeah, and all those things had this mechanical equivalence to them. Everybody understood that you can't get any free energy, and twice the speed of the wheel is going to be twice the energy, not 4 times the energy.
Something incredible happened. Humans developed machines that were capable of processing extraordinary amounts of energy to carry out previously unimaginable.
So it's not all that extraordinary, but the fact is, yes, you could build a furnace, and you could you could convert a lot of chemistry into photons, and cause a lot of atoms to jiggle.
Tasks. Now, this happened thanks to many people and for many different reasons, but I'd like to begin this story with one of the most intriguing characters in the history of science.
Right, so he calls him intriguing. He didn't bring up the fact that he actually stole calculus, and it's pretty obvious he did. He's forged documents trying to pretend he didn't. Just leave all the history. Leave all the truth out of the story.
One of the first to attempt to understand energy.
So, and again, all he understood was God, 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 God. Okay, his whole philosophy was based on everything as a spirit, as a soul, monads and solitons. First you become a monad, and then you can become a soliton. Blah 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 blah. It's all kinds of just rubbish. He actually, for a good part of his life, believed that if I threw a pea at a boulder, and the pea was going 50 miles an hour, I could make both the boulder and the pea keep going at 50 miles an hour. That's how much he understood momentum. Get to it.
Gottfried Leibniz was a diplomat, scientist, philosopher, and genius.
Lawyer. Whatever. He was very well, very literate, okay? And he read everything. And he talked to everybody. So, yeah. But how much of it was his invention? That's the tricky part.
He was forever trying to understand the mechanisms that made the universe work.
Yeah, the only thing he cared about is how it relates to God. So again, it always came back to God, 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 God. He was a religious fanatic. He thought, Newton and Descartes were a threat to religion. They needed to be censored. He wanted to throw them like Galileo. He wanted to throw them in jail.
Leibniz, like several of his great contemporaries, was absolutely convinced that the world we see around us is a vast machine designed by a powerful and wise person.
So why don't they just say what he said, which is it's the best of all possible worlds, because anything that happens, God must have thought it was a great idea. That's the only way it could happen. I mean, it's just such garbage.
And if you could understand how machines worked, you could therefore understand how the universe and the principles that have been used to make the universe.
All right, so there weren't any machines. So again, it's, what kind of machines were there really?
Worked as well. And so there was
So he didn't understand the law of the lever, okay? Because obviously the law of the lever is in direct contradiction to mv squared being conserved. So you can't believe in the law of the lever and say, oh yeah, mv squared is the real definition of energy, because the two are in direct contradiction.
Extremely close relationship for Leibniz between theology and philosophy on the one hand and engineering and mechanics on the other.
Yeah, there wasn't two things. It was just his religion, and he tried to force physics to be a religion.
It was this relationship between philosophy and engineering that in 1676 would lead him to investigate what at first sight seemed to be a very simple question.
So there's nothing in here, so they're not going to talk about mv squared. It doesn't come up in the entire video. So just understand, his definition of energy, they're not even going to cite the sense of it. They never even say the word momentum either. So they're going to talk about energy, and they're not going to talk about either kinetic energy or momentum.
What happens when objects collide?
Yeah, what happens when you drop 4 pounds 1 foot and then you drop 1 pound 4 feet? Well, the 1 pound drop 4 feet takes twice as long to fall, not 4 times as long to fall. It's only in the gravity twice as long. It only gets 2 units of 9.8 because it's only going twice the velocity. It's not going 4 times the velocity, it's only twice the velocity. So a 1 mass going twice the velocity is not the same energy as a 4 mass going 1 velocity. The law of the lever proves that. So that's the nonsense. I mean, something so obviously in conflict with, can't think of his name, but the guy who invented everything else. The screw and all that, the gold and measuring how many atoms it had and all that kind of stuff, whatever his name was.
This is what Leibniz and many of his contemporaries were grappling with. So when these two balls bump into each other, the movement of one gets transferred to the other.
Yeah, and the trick of it is, by his conservation of kinetic energy, mv squared, that every time you crash a heavy thing into a light thing, you make free energy. Not a good idea.
It's as though something's being passed between them. And this is what Leibniz called the living force.
Right. All it has to be called is the force, period. And all you're doing is exchanging the force from one object to the other. You're exchanging a bias. So the electrons were being pushed in this ball, and then when they hit the other ball through the transfer of the atoms between the contact point, all of that motion of those electrons just flew right into the other ball, because it's the whole elastic inelastic rules.
He thought of it as stuff, as a real physical substance.
And it's not a problem doing that. So that won't hurt you in any way. Okay, if you understand energy, motion, to be something that you can transfer, like you do have it, a certain amount of it, and you're going to just transfer it. And in every circumstance, that analogy works. It's not a problem, because it literally is actual force that's pushing electrons and protons. And the difference is after contact, one ball has the force pushing its electrons, the other one doesn't.
That gets exchanged during collisions.
Leibniz argued that the world is a living machine, and that inside the machine there is a quantity of living force put there by God at the creation that will stay the same forever.
Right, but it's mv squared. So again, how can it stay the same? All right, every time you transfer it from light things to heavy or heavy things to light, you're going to change how much energy there is in the universe, because you're going to conserve the momentum. And when you conserve the momentum, you're not going to be able to conserve the mv squared. You can't conserve both anytime you transfer between different masses. So it's just too ridiculous.
So the amount of living force in the world will be conserved.
Right. So you could fix this whole video by just saying the amount of momentum will always be conserved. There you go. Then we're done. So whether the momentum's in a wire moving electrons, whether the momentum is heat, atoms vibrating, it doesn't matter. It's movement. The amount of movement in the universe, mass moving, will always be the same. The total mass moving. Oh, I shouldn't have said it that way, frankly. Just because you have to include the force. And the fact is that you can consolidate the matter and change how much force is being used to push the matter. So, but the energy is still in the universe. It's just in the fact that you're going to end up increasing or decreasing the amount of gravity there is. The more the matter is consolidated, the less energy there is free in the universe. And so technically you could argue that the universe expands and contracts because energy is absorbed by the contraction and it is released by the expansion.
The puzzle was to define it.
So there's only two states of force can be in. It's either pushing an electron or a proton, or it's free moving through space. That's it. There's only two states. And there's only two states a piece of matter can be in. It's either not being pushed by anything, or it's being pushed by some amount of force in a direction. And it can only collect energy in one direction. It can only move forward or move backwards or stay still, but it can't do both.
Leibniz would soon find a simple mathematical way to describe the living force.
So he's not going to tell us that simple mathematical way. It's just hilarious. He discovered a simple mv squared. That's the only thing he did mathematically. There's nothing else he did.
But he would also see something else. He realized that in gunpowder, fire, and steam, his living force was being released in violent and powerful ways.
Right, and that's why we're using it. It's because it's got a lot of energy. So there was no new news flash there, right? The cannon wasn't a big surprise, was it?
If this could be harnessed, it could give humankind unimaginable power.
So I have seen no evidence that Leibniz said anything like that. So blah, 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 blah. So all this mush, all this, this, this is what you need. You have to have all this bullshit in your science.
Leibniz would soon become fascinated with ways of capturing the living force.
So I didn't see any evidence of that either, him making any capturing devices. So more talk. He didn't do any, there's no evidence that he did any experiments regarding mv squared and demonstrating its reality. All he did was state it as an axiom that 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. And that was it. He never demonstrated it to be true.
A prolific letter writer, Leibniz struck up correspondence with a young French scientist called Denis Papin.
All right, so I haven't seen the Papin letters. I saw lots of other letters.
As they corresponded, Leibniz and Papin realized the living force released in certain situations could indeed be harnessed.
So that's not a surprise either, right? I guess we'll pause, get rid of the commercials. All right, maybe I'll take this opportunity to just draw a simple example real quick, throw in there. One I've done so many times, but I might as well, all right, so it's the simple argument about you got a 5 mass and you're giving it a velocity. So we give it a 10 velocity. And then all we're going to do is add 5 to it. And we're going to do it as gracefully as possible. And the trick is, no matter how graceful we are, like there's no possibility of doing it gracefully enough. The trick is you always have to lose 1/2 of the kinetic energy. So 1/2 of the energy that this has, so imagine if it was a train, okay? 1/2 of its energy has to be lost, at least 1/2. You can lose more, by not doing it very gracefully, okay? So if I don't add this 5 mass gracefully, I can lose some momentum, all right, here, all right? But if I do it as gracefully as possible, I will conserve 99, maybe even 0.5% of the momentum. So very little momentum lost. But I lost 1/2 the kinetic energy. And I can't change this fact. This fact cannot be changed. So no matter how gracefully I do it, I have to somehow, and these people will actually argue this, I have to create half the energy that the train has in heat. So no matter how gracefully I connect these two things, somehow I'm going to create half the value. So, you could be talking about thousands of joules of energy, right? 20,000 joules of heat. Now, there's no evidence that this ever happens. There's any heat at all. The experiment's been done a ton of times, and there's no evidence of any carts cracking or any, anything catching fire, any sparks, any real problem. And this number proves the point. And the same thing happens with the ballistic pendulum. It's automatic. I can't change this result. Okay, the bullet goes in, and I have to lose 99.9%. This is if I actually conserve all of the momentum. All right. Now I don't know if there's any ballistic pendulum good enough to do that, but it's about 95 at least % of the momentum will be conserved. So I'll conserve 95% of the momentum, and I'll lose almost all of the kinetic energy. I mean, so much that it's a joke. It's not, 99.4%, 94. Huge amount of kinetic energy gone. So, I mean, and I can't change this fact. I can't change this number. I can't do the experiment some other way and change it because it's built in to the fact that the bullet has the preposterously high velocity. Okay, it's got the gigantic V and the very tiny mass, and the outcome is going to be a gigantic mass, okay, and a very tiny V. And that squared function means I'm doomed here. I'm always going to have to do this. And their argument is so no matter what this experiment I design, I can't catch the bullet without creating a huge amount of heat. Not a small amount, a gigantic amount. There's absolutely no evidence of that. So I'm just saying, this is mathematical nonsense. It doesn't make any sense. And again, it violates the law of the lever, which plainly states that, that if I want to make something equal to 4 pounds with one velocity, then I have to do 2 pounds, okay, with 2 velocity, or I have to do 1 with 4. That's the law of the lever. And it doesn't match kinetic energy. It doesn't match their argument. It doesn't match 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. It's just not true. All right. So again, he hasn't said anything about Leibniz's theory, okay, and what he's offering. Now again, Huygens also argued for mv squared, but clearly Huygens, people didn't pay as much attention when Huygens did it for whatever reason. And obviously de Châtelet has a lot to do with making this a real subject again. So a few years after Leibniz's death, she resurrected this controversy between a momentum and kinetic energy and did the famous denting of clay garbage experiments and such. Okay, play. Maybe I should hit this button. Safer.
A form of useful action.
So he's basically saying heat could be turned into something useful. Now, we already knew that, right? I mean, everybody knew, but even back then, they knew what convection was. So they knew heat could move atoms. So, it's hardly, again, this isn't something one person thought of. It's just ridiculous. Clearly, lots of people. And I found no evidence that Leibniz was the first person to suggest maybe we could make a heat engine. Not even close.
But how far could this idea be taken? Papin was in no doubt. This is an extract from his letter to Leibniz. I can assure you that the more I go forward, the more I find reason to think highly of this invention, which in theory may augment the powers of man to infinity. But in practice, I believe...
So he's talking about infinite amounts of energies. That's kind of silly, right? So he's really not getting what heat is. All right, but anyway.
I can say without exaggeration that one man by this means will be able to do as much as 100 others can do without it.
So the fact that they were noticing that there are stores of energy, you could just say that a geyser, there's so many things that would give you evidence that there's lots of energies to be grabbed, and you just have to find a way of grabbing them. I mean, volcanoes, huge amount of energy.
Now, you might expect me at this point to tell you that Leibniz and Papin changed the world forever. Well, they hadn't. Their ideas had been profound and far-reaching, yes, but
No. Their ideas were common, and everybody was already talking about it. So that's the bullshit here, is that this is all stuff. I mean, again, even Leibniz hated Descartes, but I mean, certainly Descartes also argued for a mechanical universe. So I mean, this is not they're making this into something when like somehow one guy figured out the round wheel, you know. And no,
Hadn't really moved things forward. For that, you need something much more.
So again, no mention of mv squared, what the living force really was, which was this change from understanding momentum being conserved in the universe to this crazy crap that this mv squared thing is conserved.
Tangible. You need innovation, industry. You need countless skilled workers and craftsmen who are going to apply these ideas, to experiment with them in novel and new ways.
You just need time, right? And obviously that's the whole evolution of human beings. Took us time, you know, Galilean telescope, and then Newton made his improvements, and same with microscope, same with all the technology. You just incrementally make it better. No big deal.
Well, in the century that followed, Leibniz...
I mean, the big failure is that you get stuck in these religious holes, this dogmatic nonsense where you declare something the truth and you never proved it to be true.
and Papin, this would take place in the most dramatic way.
In spite of the fact that there's a direct logical contradiction with the other things you say. So again, their bent space is in direct contradiction to their quantum mechanics, wave-particle duality. I mean, none of it makes any sense. I mean, the inconsistencies within their own theory should be reason enough for somebody to say, oh, fuck, start over.
Imaginable. A 150 years after Leibniz and Papin's...
So we know that the argument happened 10 years after Leibniz's death, and that Deschardelet won with a crap show experiment. You know, like I said, people were fooled by something as silly as, you know, rolling, you know, something twice as fast and it rolls 4 times as far. Because they really didn't think about the fact that, yeah, but it's only rolling twice as long. You know, it doesn't take 4 times the time.
Discussions, the living force had been harnessed in spectacular ways. The machines, they...
So the living force, no, momentum. And all you're really doing is trying to find ways to take advantage of direction. So I guess the key word I'd say here is this is just about direction. So you want to take energy that's going in all directions, you want to make it go in one direction. That's the key to the whole thing. And how do you make heat go in one direction? Well, you put something cold next to it. Okay. Have this all the same temperature, and then have just one place where it's cold, and then the heat will go in that direction. So that's the key to changing the direction of the heat, is to change the size of your sink, the cold thing. The smaller you can make the cold thing, the more directionality you're going to get out of the heat.
Dreamed of had become a reality. Steam engines were now the cutting edge of 19th century technology.
And steam engines are about, again, expansions. So again, we're talking about taking atoms, our molecules, and expanding them. Okay, so using heat to cause an expansion in the volume of space that the stuff takes up. So gasoline, I think he's going to point out later in this video, is 2,000 times. And so the expansion is 2,000 times as much space the atoms are taking up.
If you look at steps in civilization, then one great step was the steam engine, because it replaced muscle, animal muscle, including our muscle, by steam power. And the steam power was effectively limitless and hugely...
So again, limitless is kind of silly talk, right? It's not limitless. And again, nuclear power relies on the mechanism of heat, just stealing the heat and then giving it directionality. And you give it directionality by moving a piston, okay, by having an expansion. It goes in all directions. It's like the bullet inside the gun. Well, it's probably not a great example because actually the that reaction is so quick that the bullet isn't really moved by the vessel's pressure, okay, where the steam engine, it's just about the pressure in the cylinder.
Important to doing almost unimaginable things.
But steam technology would do more than just transform human society. It would uncover the truth about what Leibniz had called the living force and reveal new insights about the workings of our universe.
So again, he keeps referencing Leibniz. Leibniz didn't say anything profound on the subject. And again, it's just the kinetic energy formula, okay, the mv squared crap. So, and again, he doesn't use kinetic energy or momentum anywhere in this video. So it's a video about energy, and it doesn't mention the duality problem.
This is Cross Ness in southeast London. It's an incredible industrial cathedral and home to some of the most impressive Victorian steam engines ever built.
So all of this is just such a waste because he doesn't really explain how steam engines were improved, the stuff that made the difference, like, using the condensator and, different things you could do to make the engines work more efficiently.
Constructed in 1854, Cross Ness houses 4 huge engines that once required 5,000 tons of coal each year to drive their 47-ton beams.
Everything about this place seems to have been built to impress. From the lavish ironwork, the grand pillars like something out of a Greek or Roman temple. It's the sort of effort you'd think would have been lavished on a luxury ocean liner for the rich and famous.
Well, even there you'd say, why would you do all this in a place that nobody sees? Yeah, but the irony is it's a sewage plant. Hilarious.
And yet this place was built to process sewage. Although only a few workers and engineers would have seen the insides of this place, steam had become such a vital part of British power and
insanity. Now this is insanity. All this ornate crap inside of a industrial machine place is just somebody wanted to waste a lot of money.
Economic prosperity, that it was afforded almost religious respect.
Well, this is a bad thing, this religious respect crap. I mean, it's scary even when scientists are talking about religion getting any respect. Religion is the first way to fuck a brain. So all of this, like I said, nothing instructional here at all.
But for all the great success and immense power that engines were bestowing on their creators, there was still a great deal of confusion and mystery surrounding exactly how and why they worked. In particular, questions like how efficient could they be made? Were there limits to their power? Ultimately, people wanted to know just what might it be possible to achieve with steam.
So that only becomes interesting just because of Joule and the fact that, he deliberately, wanted to find some way to measure efficiencies and measure the exact energy and all of that stuff. And whether electricity, in his case, later on, whether electricity was more efficient, an electric motor versus a steam engine.
The reason these questions persisted was simple. Almost no one had understood the fundamental nature of the steam engine. Very few were aware of the cosmic principle which underpinned it.
These great lumbering machines that we think of as the early steam engines actually were the seed of understanding of everything that goes on in the universe.
So way overhyped, and again, it's just a transfer. You're just transferring energy, motion from one thing to another.
As unlikely as it sounds, steam engines held within them the secrets of the cosmos.
So all of this is just to say heat flows from hot to cold. High pressure, low pressure. It doesn't go from low pressure to high pressure. I mean, that somehow the thing with more momentum wins. Yeah, that's how it works. I don't know what that was. And now for something completely different.
This is the Château de Vincennes in Paris. Events here would motivate one man's journey to uncover the cosmic truth about the steam engine and help to create a new science, the science of heat and motion.
So this is the Carnot guy, I think, and look, again, they don't really quote anything and prove anything and show anything like what the great innovation here was, because in my opinion there really wasn't one.
Thermodynamics.
So, and it means nothing, thermodynamics, right? I mean, it's like saying light speed. It's just not getting to the point where all you're doing is transferring momentum. That's it. There's nothing else to do. Motion. One thing moves, it bangs into something else, and they exchange some portion of their motion. Or it radiates, directly a force. But it can't radiate the force without losing whatever its momentum was, its heat.
In March 1814, during the Napoleonic Wars, when Napoleon and his armies were fighting elsewhere, Paris itself came under sustained attack from the combined forces of Russia, Prussia, and Austria.
I wonder why they didn't take over since they won. It's kind of funny how the French could lose wars and still stay French.
And citizens of the city were deployed around key locations to protect them. Now, this chateau was being defended by a group of inexperienced young students who were forced to retreat under sustained artillery fire. One of them was a brilliant young scientist and soldier. His name was Nicolas Léonard Sadi Carnot, and the humiliation he felt personally would drive him and motivate him to uncover profound insights into how all engines work.
I think his father was also into this whole stuff too, but so there was no mention of that, so I don't know.
Carnot came from a highly respected military family. After the French defeat here and elsewhere around Europe, he became determined to reclaim French pride.
Yeah, so did he do any of that stuff? What exactly were his innovations to the steam engine? blah, 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 blah.
What really bothered Carnot was the technological superiority that France's enemies seemed to possess. And Britain in particular had this huge advantage, both militarily and economically, because of its mastery of steam power. So Carnot vowed to really try and understand how steam engines work and use that knowledge for the benefit of France.
So, who knows how much sense this even makes. Probably has to do with how many ships you have and how much hardware, and how much is spent on your military. And the French were not as well off, and so they, couldn't build as big an army. And the fact that he just pointed out that Napoleon was busy elsewhere.
He says absolutely explicitly that if you could take away steam engines from Britain, then the British Empire would collapse. And he's writing in the wake of French military defeat.
The world's first titanium.
Shit.
Analyze, literally, the source of British power by analysing the way in which fire and heat engines work.
Living on half pay with his brother Hippolyte in a small apartment in Paris, in 1824, Carnot wrote the now legendary Reflections on the Motive Power of Fire. In just under 60 pages, he developed and abstracted the fundamental way in which all heat engines work.
So, I don't, they're all pressure engines. So again, there's sort of a deception here to say that all you have to have is heat to be able to do this transfer, because you have to convert the heat into something expanding, frankly. And if you don't do that, I don't think the mere conveyance of a heat can do you any good. You have to use the heat to create the expansion.
Carnot saw that all heat engines comprised of a hot source in cooler surroundings. Now, Carnot believed that heat was some kind of substance that would flow like water from the hot to the cool. And just like water falling from a height, the flow of heat could be tapped to do useful work.
So that's sort of like convection, okay? But that, again, that's the one that's not the stronger. I'm just trying to think of the right way to say it. You can't move heat unless there is a place for it to go. So it's almost like you can't depressurize a balloon unless there's a place for the pressure where there's less pressure. So obviously.
Carnot's crucial insight was to show that to make any heat engine more efficient, all you had to do was to increase the difference in temperature between the heat source and the cooler surroundings.
Right, and that's not an easy task either. Pulling the heat out of something is just as much work as putting the heat into something. So it's not like there's magic there either, but obviously that's why, trains have a giant pile of water in them.
This idea has guided engineers for 200 years. Ultimately, a car engine is more efficient than a steam engine because it runs at a much hotter temperature.
Yeah, and there's, you have the coolant system that has to take some of the residual heat away, but there's no real effort to make the engine colder. Okay. You just allow there to be some waste.
Jet engines are more efficient still, thanks to the incredible temperatures they can run at.
So it's not even a picture of a jet.
Carnot had revealed that heat engines weren't just a clever invention. They were tapping into a deeper property of nature.
All right, so my argument is there's not this deeper property. Energy can go either way. in the sense of it can go to big things or it can go to smaller things. It can be directed or it can be scattered. There's nothing stopping you from making a laser beam, and there's nothing stopping you from making a diffraction gradient and shooting light all over the place.
They were exploiting the flow of energy between hot and cold.
It's the creation of the pressure. So, I mean, frankly, that's there's motion and no motion, and you can't take something that's moving, okay, and move it into something moving. If the other thing's moving more than you're moving, then you're going to get moved. Again, the thing with more momentum wins. You're just saying that, yes, momentum travels from things with more momentum to things with less momentum.
Carnot had glimpsed the true nature of heat engines, and in the process begun a new branch of science. But he would never see the impact his idea would have on the world.
I should look up his book, I guess, and see if there's an English version of it. Be interesting, I think, to read, but yeah.
In 1832, a cholera epidemic spread through Paris. It was so severe it would kill almost 19,000 people.
Yes, and that's not all that many. It's a lot, but it's not, a lot worse epidemics. But anyway, so he got killed by it. Just more of this, part of the fun of being alive. Getting killed by cholera.
Now, back then, there was no real scientific understanding of how the disease spread, so it must have been terrifying. Carnot, undaunted by the risks, decided to study and document the spread of the disease. But unfortunately, he contracted it himself and was dead a day later. He was just 36 years old. A lot of his precious scientific papers were burnt to stop the spread of contagion, and his ideas fell into temporary obscurity. It seems...
Well, the book was already written, so blah, 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 but whatever. Maybe he had some new ideas.
The world wasn't quite ready for Carnot.
Again, this had already been talked about, 100 years earlier. About the nature of motion and the fact that the little motion of the little stuff inside of something, the vibrations, the idea that you could bang two pieces of clay into each other and the clay would move and it would get hot. I mean, these were things they had observed already.
Carnot had made the first great contribution to the science of thermodynamics. But as the 19th century progressed, the study of heat, motion, and energy began to grip the wider scientific community. Soon, it was realized that these ideas could do much more than simply explain how heat engines worked. Just as Leibniz had suspected with his notion of living force, these ideas were applicable on a much grander scale.
All right, so just this whole idea of the living force, even using that rhetoric, and, it's just such nonsense and gibberish. It's a mechanical universe. The force isn't alive. It's all this, very precise stuff. It's a bunch of little crap with precise trajectories and precise outcomes, and it's just such bullshit. Anyway, even living things are just machines living out a mechanical sentence to interact in a narrow and confined environment of possibilities where there's only one inevitability. But anyway, all right, so I think we'll call this a video, and I'll come back to this, I guess, 20 minutes in. Got a ways to go. We'll see. But I'm just saying the basic point is that they're arguing for this idea that somehow energy only goes in that one direction. And the argument is gravity is the opposite. Gravity is where it gets repressurized. it depressurizes, scatters, and then gravity repressurizes. All right. Oh, till the next time, and such and so forth and whatnot.